we need to talk about, yikes, that's not cooperating. We are going to talk about, I need you to think about what our 30-degree reference angles are in each of the quadrants, and our 45-degree reference angles in each quadrant, and our 60-degree reference angles in each quadrant. So I need you to think about what that means, right? Okay, so if we have, I want to do a different color than what I'm dealing with there. So our 30-degree reference angle in quadrant 1 is just 30 degrees, right? We rotate up to 30 degrees. If you think about what the 30-degree reference angle in quadrant 2 would look like, it means we're at this particular place, but we're going back 30 degrees, excuse me, in order to draw that triangle so that this is 30 degrees. Just watch for right now, okay? You don't need to write anything, just watch. If we're going back 30 degrees, so think about the fact that what that means we need to do is 180 minus 30 in order to figure out what that 30-degree reference angle is in quadrant 2. So 180 minus 30, what does that give us? Thank you. Yes, 150. Okay. And then our 30-degree reference angle in quadrant 3 means we're going down here and we're going 30 degrees more from a full 180. So if we do 180 plus 30, how much does that give us? 210, yeah. And then lastly, our 30-degree reference angle in quadrant 4 would create a triangle that looks like this, and this is our 30-degree angle. So really, if you think about it, what that's saying is that we're going just 30 degrees short of a full 360. So 360 minus 30, and that gives us what? 330. There you go. Guys, those are our 30-degree reference angles. Get those written down on that front page, if you would. Yes, you need to get those memorized. There's going to be a lot that I'm going to throw at you here today, and you're going to have to get a lot memorized. So flashcards, that type of thing for sure, okay? So I want to do similar process for coming up with and figuring out what our 45-degree reference angles are in each quadrant, and then what our 60-degree reference angles are in each quadrant. So similar process. So to get the quadrant 2 reference angle for 45 degrees, we're going to do 180 minus 45, which gives us 135. And then 180 plus 45, which gives us 225. And then 360 minus 45 gives us 315 degrees. Okay? So that's our 45-degree reference angles. Now let's talk 60s. So similar process. We know it's 60 degrees in quadrant 1. If we do 180 minus 60, we're at 120 degrees. If we do 180 plus 60, think about the math there, that's 240 degrees. And then 360 minus 60 will be at 300 degrees. Okay? So we're going to use this information today, but you're going to need this basically for the whole rest of the semester as well. You need to know, the nice thing is, if you notice, all of the 45-degree reference angles, they end in a 5, right? So that's kind of a hint. If you see an angle that we're talking about on the unit circle and it ends in a 5, you know it's a 45-degree reference angle, right? The 30s and the 60s, those take a little bit more time to kind of get memorized. Okay? All right. Hold that thought. Do me a favor, grab your plate. And if you would, you're going to fold it in half. And my suggestion, what I'm going to ask you to do is while you are folding it in half, the other thing we kind of want to, did you not grab a plate, Susie?
No, I thought you said no.
Just don't grab 2 plates, you just need 1.
Oh, for me.
Everyone needs 1 plate. Okay, fold it in half. And we kind of want to work on flattening out these ridges on the plate as well. So try to flatten those out. And then get a pretty good crease on that as well. And that first fold, and then fold in half again so that it looks like a quarter of a pie slice. And get a pretty good crease on that one, and then you can kind of try to flatten out those ridges a little bit more on that. Kind of putting it on the desk and kind of rubbing your finger over it, I think helps with trying to flatten out those ridges. Okay. Okay, then I need for you to open that back up. And if you notice, I've drawn, I've got to explain how you're going to do this. Use your straight edge and use a pencil, please, not your Sharpie right away. So use your straight edge and pencil to draw these lines where you've done the crease, and then go back just freehand with the thicker Sharpie or highlighter that you have to darken those lines. I just don't want to get Sharpie all over the edge of those rulers, okay?
Can I use a marker instead of a Sharpie?
I'm sorry?
Can I use a marker instead of a Sharpie to go?
Well, I just don't want to get, I want to keep this clean.
Oh, yeah,
If you use
yeah.
a marker, you're gonna,
Still get it.
yeah, so don't, like, you're doing freehand once you've drawn in the lines with your pencil. But yeah, then I want you to go over it with a thicker line there, right?
Yeah.
Okay. Okay. We need to label here. Right? This is, I need you to orient this as if this is a coordinate plane. I need you to think about the fact that we're gonna label this out here. This is 0 degrees. And then up here we know is 90. And then 180. And then 270, and I want you to add 360 here also. So go ahead and add each of those. Kind of right at the edge there is what I would suggest. Okay? And then, well, we'll go back and do that.
Miss Island, do you have an extra black Sharpie?
I don't know, you'd have to look. Okay, yeah, we'll go back and deal with the coordinates shortly. Okay. So now, bear with me. I want you to just watch because I'm going to write some stuff on the next page. We will go back and add to that shortly, but just watch for right now, okay? We're going to focus on which triangle is it? The yellow triangle to begin with. So grab that yellow triangle. And that yellow triangle corresponds to this triangle X that's on the first page of your notes packet, okay? So I'm gonna write here on this page, just watch for right now. Here's what I need you to think about, okay? That yellow triangle is a 30, 60, 90 triangle. I'm gonna try to color code here if I can. So this is a 30, that means that's 30 degrees, this is 60 degrees. And I need you to think about your Pythagorean triples and think back to your geometry days. We learned that a 30, 60, 90 triangle has the Pythagorean triple that we use, that is the 1 square root of 3, 2, right? So you have to think about and remember the fact that the 1 goes opposite the 30-degree angle. The square root of 3 is longer, so obviously it has to go on the side opposite the 60-degree angle. And then our hypotenuse is 2. Okay? All right, so here's where I need you to think about your yellow triangle. If you notice, along the hypotenuse of this yellow triangle is labeled 1 unit. That's why we call it a unit circle, is for convenience sake, we want the radius to be equal to 1, and you'll see why here in a little while, I promise. But we need the radius, or the hypotenuse, to be equal to 1, okay? So I need you to think about this particular triangle then. We basically have to rescale it, right? If we want this side to be 1, a length of 1 rather than 2, it means we have to divide that side by 2 in order to get to the 1. So think about the fact that that means we're going to have to divide each of these sides by 2 also, right? So that corresponds then to this 30-degree angle, which is your yellow triangle. So grab your yellow triangle. And I need you to realize the hypotenuse is already labeled as 1 unit. I need you to realize then that what this is saying is that this height, this length, is 1/2, and this length is the square root of 3 over 2. So label that yellow triangle for me, if you would. With that 1/2 and that square root of 3 over 2. And actually, while we're on this page, let's go ahead and label this point as 30 degrees. And let's put that coordinate there, right? So if we imagine moving this triangle and sliding it up into position here, think about what the distance is along the x-axis, the bottom length, and that's the square root of 3 over 2. And then we are going up 1/2. So we'll go ahead and label that up there on that. Okay, so our unit circle, it has a radius of 1, right? But the distance that we're going to be going out to some of these points, it can't all be 1, right? It's going to be smaller values there. So at that 30 degrees, those are the 2 coordinates to get to that particular triangle. Okay, so far so good? All right, so now we are going to go to our plate. So we're back up here on the front. And pick a color that you want to use. And we want to set this, we want to basically draw in our 30-degree reference angles in each quadrant of this. Okay, so watch how we're going to do this. Please try to be pretty careful about lining this up along the positive x-axis. But then you just want to extend this line beyond where, like, You don't need to draw that whole line, we're gonna get that with our straight edge, but extend this line out to that particular point. Okay,
Mine's cut all weird, like, should I still like trace?
what now?
My thing's like cut all weird, it's not like should I still trace it like how it is?
Go straight from the end of that top part there.
Oh, so
It doesn't
here,
matter
got
about
it.
the bottom there, it's just across the top here. Okay, now I need you to think about this, to make sure that we keep this 30-degree angle just above or just below this x-axis. We gotta flip this over, right? So let's flip this over, and using that same colored pen, because we want all of these 30-degree reference angles to be same color. So there's next 30-degree angle, we'll label it in just a second. And then we need to flip down so that we're doing the 30 degrees beyond 180. Down to here. And then we have to kind of reflect it again, flip it over again, down below here and extend. Okay. All right, now you can set that, just kind of set it off to the side for a second. We'll get back to that in just a second. We need to draw lines, so use your straight edge and draw lines to connect from where that is to through the center, and you can just extend it all the way on to that next. Right, so extend it and go all the way through. Make sure you're drawing not just the radius, but the diameter. Okay. I'm gonna go ahead and write these up here too. Okay. Are we good with that? Now we need to label these angle measures. We need to label what the degrees are. So we want to kind of progress through the quadrants with our 30-degree reference angles. So in quadrant 1, we know this is 30 degrees. In quadrant 2, we know this is 150 degrees. Down here, we're at 210 degrees. And then 360 minus 30, we're at 330 degrees. Okay. Let's use that same colored pen. We're gonna write in our coordinates. Guys, here's the thing that's so pretty about the unit circle. For me personally, what I'm gonna suggest that you do is that you focus your attention and you try to memorize everything you can from quadrant 1. Because if you can learn and memorize all of the information that you need about quadrant 1, then it's really simple just to extend that to the other quadrants. If you know all of your 30-degree reference angles, anytime you see any of these 30-degree reference angles, what's true about one in terms of the coordinates is gonna be true for all of them. The only difference is, if you think about it, in each quadrant, our signs will be different, right? So that's what we're gonna label here. So if you look at your 30 degrees, I'm gonna do the labeling of my coordinates in a little bit, actually, kind of like right here in this middle section here. So in this middle section, if you think about it, if we go out, think about what this was telling us. We're going out 3 pi over, root square root of 3 pi over 2 plus, then we're going up this 1/2. So that's the coordinate, that's what we wrote in on our note packet in the note packet for that. We wanna do that same thing here. right? So square root of 3 over 2, comma 1/2. Thank you. Okay, so now think about what the coordinates would be for this point over in quadrant 2. What's the difference in what the coordinate's gonna look like? What do we know about x values in quadrant 2? They're negative. What about the y's? The y's are positive. So the only difference here is that over here, we're still going to have the same numbers in the same place, only now this needs to be a negative square root of 3 over 2, and then 1/2. Right? Think about quadrant 3 down here at 210 degrees. Same exact numbers. What do we know about the x value and the y value in quadrant 3? They're both negative. So negative square root of 3 over 2, comma negative 1/2. Oh. You rock. Thank you.
Yeah.
There's Jen. Oh, thank you. Okay. All right, and then lastly, quadrant 4. Positive square root of 3 over 2, and then a negative 1/2. Okay? Thank you very much. Okay. All right. Okay, what do you think? So far, so good? Questions? Kind of makes sense, I hope? Okay, we're going to do that exact same process. Thank you. Emily, Allison, you can pass off your plate. Thank you very much. One of you can just pass your plate on to him. Okay. Jace, where are you? You are up here with Finley, next to Finley Grace. Okay. Next, back to that page in your textbook, in your notes packet, we need to look at the pink triangle. Okay, so think about that pink triangle. And in this case, what did I label this over here? So it's triangle Y on that page in your notes packet. The pink triangle is a 45, 45, 90 triangle. Okay? And we know from geometry that our 45, 45, 90 triangle corresponds in our Pythagorean triples as that 1, 1 square root of 2. Right? That's our 1, 1 square root of 2 triangle Pythagorean triple. So I need you to think about how that's going to work if we want to be in the unit circle, where we need a radius of 1. So what do we need to divide by in this particular triangle so that we can get that radius of 1? What do we have to divide by? Square root of 2. So we divide by the square root of 2 here. That gives us our 1. If we divide this by the square root of 2, well, guys, we know we have to rationalize denominators if there's a radical. So instead of writing that as 1 over the square root of 2, I want to rationalize that. So it's going to be square root of 2 over 2. And then similarly here, if I divide by that square root of 2, this will also become the square root of 2 over 2. So let's go ahead and put this up here on this page. So you're 45 degrees. I'm sorry, write it on here first. if that's gonna help on your pink triangle, think about what that's telling us the length of each of those sides is, right? The length of the side along the bottom, the base, is square root of 2 over 2, and then the side going up is also square root of 2 over 2, right? So that corresponds then to coordinate points here at 45 degrees as root 2 over 2, comma, root 2 over 2. So it's not very pretty looking, but it's nice to know that at that 45-degree angle, the numbers are exactly the same. It makes it easier in terms of memorizing, because yes, this is something you're going to have to get memorized. I am going to try to teach you a whole bunch of different ways to kind of work through this and process and get this memorized, okay? Okay, so far so good? Okay, so now what did we come up with here? So let me get this written in because we're gonna write these values in just a second. So remember our 45, after that, what was it? 135. Francis, what was the next one?
225.
225. Ryder, what's the last one?
315.
315. Okay, so those are our 45-degree reference angles in each of our quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, so let's go back to our plate. We're going to draw in our 45-degree angles, draw in those lines. So similar to what we just did with those 30s, we're going to do same process here. Different colored pen. So with that pink triangle, first thing is to put the triangle into place and extend that line. Whoops, there we go, you can kind of see that. Make sure you're flipping it, right, so that you can get that angle correct there, and then flip it again. Go ahead and use your straight edge. Once you've drawn in those, use your straight edge to draw all the way across. So mine only goes to the center, but you can, with your straight edge, you can go all the way across in one. It's a little hard to see. I hope you can see it up there in the orange. It's light, but I think you can see it. Okay, so you've measured your 45-degree angles. Now you're drawing in those lines, and they can go way up all the way across in that unit circle. All right? I'll give you a second to do that, and then I want to go through, we're going to do the same process as we just kind of did with the 30-degree angles. I want to put in the degree measures first, and then we'll go back and put in the coordinates. Okay? Okay, so these are our 45-degree reference angles. So in quadrant 1, the first one there is just 45 degrees. Okay, what about in quadrant 2? Someone call it out. Oh my gosh, are you guys not awake this morning? Help me out here.
135.
Thank you, 135 degrees. Down here, the 45-degree reference angle is 225, yep, good. And then lastly, Caden, 45-degree reference angle in quadrant 4. 315 degrees. Okay, so we have our degree measures labeled. Now we want to label our coordinates, just like we did up here, right? So we're going to use the same coordinates, only we switch the signs in each quadrant, right? So in quadrant 1, we know it's still going to be square root of 2 over 2, comma, square root of 2 over 2. that's for 45 degrees, okay? Now we are over here at 135 degrees, that's quadrant 2, so what do we know about the x-coordinate? It's negative, our y value is positive, so this is gonna be negative square root of 2 over 2, comma, positive square root of 2 over 2. Quadrant 3, both x and y are both negative, so it's gonna be negative square root of 2 over 2, comma, negative square root of 2 over 2.
There's more
You
like
guys
this
draw.
downstairs
Okay.
if you need more.
Danielle came running,
All
Jen
right.
came running, you came running, thank you all so much.
We love you.
Yeah. Okay. So that's negative and negative down in quadrant 3. So think about quadrant 4. We're going positive and then negative. So positive square root of 2 over 2, comma, negative square root of 2 over 2. We're getting there,
Can
guys.
you go up a little bit? Sorry.
What are you looking at? Which quadrant?
Quadrants, 1 and 2.
Okay, there you go.
Back to my ones.
Oh, keep that. Okay. Now we've got to talk 60 degrees. So let's go back to our triangle on that first page in our notes packet. And let's think about that. Yikes, where did I put, here it is. Okay, so this is triangle Z on the bottom of your page, right? It's a 30, 60, 90, but now our 60 degree angle is down low and our 30 degree angle is up high. So this doesn't change, it changes a couple subtle little things, but that's it, right? Our 30, 60, 90 is still gonna be 1 across from the 30 degree angle, square root of 3 across from the 60 degree angle, and then this is 2. So once again, we've kind of got that similar issue as we did with the 30 degree angle, where to get our 60 degree angle here, what do we have to divide that 2 by in order to have a radius or hypotenuse of 1 for our unit circle? We are dividing by how much? 2. So this becomes 1. This side becomes the square root of 3 over 2, and this side is 1/2. Okay. Think about what that corresponds to up here on this up above. So if you want to get this labeled in, we'll label in a few other things here shortly onto this visual. So 60 degrees, and if you look, our base, the length, if you look at this, think about it, kind of look on the page here, if you notice, we're going the shortest distance over to the right. We're going the tallest distance up to get to that point. So we're going over 1/2, we're going up square root of 3 over 2. Does that kind of, do you see that? Okay, so in terms of memorizing, it gets tricky with keeping straight which one's the square root of 3 over 2, comma 1/2, and which one's the 1/2, comma square root of 3 over 2. I'm going to give you a few different ways to kind of think through that to help you with that. Okay, we'll get to that. But that means in our blue triangle, how do we label the bottom of the blue triangle? The bottom square should have what in it? What value? 1/2. And along the right-hand side, that side is square root of 3 over 2. So go ahead and label this triangle, if you would. And then let's go ahead and start, let's go back to our plate. We're gonna draw in and do the same thing we did for the 30s and the 45s. Same thing here for new color, right? Use a different colored pen. We want all of our 60 degree angles to be the same color. So extend the line. Jace, have you gotten kind of caught up with what we're doing here, I hope?
Yes, ma'am.
You came in at an awkward spot to try to
Catch back up.
do this. Finley, Grace, Kira, thank you for helping him. Okay, so flip your triangle to label those, then use your straight edge to draw in the lines, and then we'll label our degrees and our coordinates. Okay, so get your lines drawn in. Oh my goodness, I just had a brain freeze. Whew, gotta love it. Okay. All right, have we gotten our lines drawn in? Are we ready to start labeling angles? So 60-degree reference angle in quadrant 1. Our 60-degree reference angle in quadrant 2 is what degree measure, Alice? 120, good. Lucy, 60-degree reference angle in quadrant 3. 240. Excellent. And Emily, 60-degree reference angle in quadrant 4. 300. There you go. Good. You staying, keeping up okay?
Yeah.
Okay. Good. Thank you very much for doing that. Okay. So we have our 60-degree reference angles labeled, right? The degree measures. Let's do the same thing now with our coordinates. So similar process. Think about what the x coordinate is going to be and the y. I have it listed up here too, and you have it on your triangle, right? The x coordinate is what? Vinay, what's the x coordinate?
1/2.
1/2, and the y coordinate is?
Square root of
3 over 2. Beautiful. Guys, what does that mean? The coordinates are going to be at 120. Think about that. It's going to be negative 1/2, comma, square root of 3 over 2. Okay, down here at 240, it's going to be negative 1/2, comma, negative square root of 3 over 2. And then lastly, at 300, it's going to be positive 1/2 square root of, I'm sorry, negative square root of 3 over 2. All right? So quadrant 2 is negative and then positive. Quadrant 3 is negative and negative. Quadrant 4 is positive and negative. Okay? All right, let's go back. I decided to wait to do this, and so now we need to think about this and get this labeled. So go back and grab your Sharpie or whatever you used for that. We don't have our coordinates written in here for our quadrantal angles, our 0 and 90 and 180 and 270. Guys, this is a unit circle. The radius is 1. So what's the coordinate at 0 degrees? What distance are we going out? If it's a unit circle, what's the radius? 1. There you go, Vinay. So the coordinate here is 1, comma 0. Right? Up here at 90 degrees, it's going to be 0, comma 1. At 180 degrees, negative 1, comma 0. And down here at 270, it's going to be 0, comma, -1. Okay. All right, we're going to take a quick brain break. There's going to be a little bit more we're going to talk about. We got to finish filling this in. And I want to talk to you about how we're going to use this unit circle. And then we'll see where we are time-wise. I'm hoping we can go back and plug in some radians. We'll see if we can get to that, okay? So quick brain break. And while we are doing that, okay. So let's finish filling in this. This is just quadrant 1, right? From your unit circle. This is just quadrant 1. What happened? Here.
Oh no, I messed that one up. I came in and started doing things, and I was like, oh, that's not right.
Okay. All right. Let's finish drawing stuff in here and labeling here, and then I want to talk to you about how we're going to use this unit circle. So we have a point here, and that's at 0 degrees or 360 degrees. And we decided that that's a distance of 1 going out, right? So this is at 1, 0. So on your notes packet, go ahead and label that. And then up here at the very top, right at 90 degrees, we know that coordinate would be at 0, 1. Okay? Yes. I'm sorry? Yes. Sorry, that's very messy. 360 degrees. Yep. Okay. All right. So here's the beauty of the unit circle and why we want to try to, as much as possible, use our unit circle. If you're just given a triangle and you don't have a hypotenuse of 1, then obviously you can't use these ideas and we have to think SOHCAHTOA like we've been doing. And now we're going to be focusing strictly on things where we can look at just our unit circle, right? So I need you to think about our ratios for the sine and the cosine and the tangent of theta. So I want you to think about our ratios using x's and y's and r's. So remember we had that memorization quiz. So for the sine ratio, what's the ratio we use to represent the sine? Rio, do you remember what the sine ratio is? Y over r, there you go. And for cosine, what is that ratio? Shane? Do you remember what that ratio is? You remember, Sophia? X over r, there you go. And then the tangent one's a little bit trickier because it is y over x. Okay, so now let's think about this for a second. Those are the ratios that we need to know, right? But now let's think about the fact that we're talking about a unit circle. And given a unit circle, we know that r is equal to what? 1. So if r is equal to 1, then when we go back and look at that sine ratio, then it's y over 1, or in other words, we just have to look at the y coordinate. For cosine, it's x over r, only r is just equal to 1, so it's really just the x. And then similarly, for the tangent's kind of its own special thing, the y over x, and we'll look at that here in just a second. So here's how we use this information. I'm gonna be asking you for exact values using our unit circle. So as an example, you may want to write these kind of down the side of the page, right where I'm writing these. If I ask you to tell me what the cosine of 30 degrees is, then we're going to go to where the 30 degrees is, and we know cosine, it means we're going to look for our x. So the cosine at 30 degrees means we're going to go to 30 degrees and we're going to look at what the x coordinate is. Well, that means that our answer is the square root of 3 over 2. Okay? if I ask you to tell me what the sine of 90 degrees is, that means we're going to go to where 90 degrees is, and we're going to look at the coordinates. And for sine, we're going to focus our attention strictly on the y. So the sine of 90 degrees, what's the y coordinate there? 1, right? Do you see that? Okay, let's try some other examples. And then I've got to talk to you about how we deal with the tangent, because the tangent's a little bit trickier. So if I ask you to tell me what the cosine of 0 degrees is, oh, let me back up, I'm not writing that correctly, because I'm trying to go too fast. So the cosine of 0 degrees. So cosine, are we looking at x or y, Eliza?
What?
For cosine.
Oh, X.
X. So for cosine, we're going to look at x. So we're going to go to where 0 degrees is, and we look at the x, and what's that value?
1.
1. So the cosine of 0 is also, 0 degrees is equal to 1, right? What about the cosine of 45 degrees? Ashley.
Maybe 1 over root 2.
Okay, only we want to rationalize that, right? So root 2 over 2. So actually that one's a little bit easier because it's either one of those, but if we're looking for cosine, remember we're going to look at the x coordinate, right? Okay, excellent. All right, for tangents, guys, I need to show you a trick. Don't write anything yet, just watch. Okay, just watch for a minute. I want you to think about the ratios for y over x and what happens. We're going to start with the tangent of 60 because that one's the easiest to see, I think. So the tangent of 60, our tangent ratio we know is y over x. So that means we're going to write, it's the square root of 3 over 2 over 1 over 2. Now, that's not very pretty, but we're going to be able to clean this up pretty easily. So just watch. I need you to think about this for a second. We have a complex fraction. We have division. So we do keep it, change it, flip it. What that means is that this flips and becomes 2 over 1. Guys, what happens with the 2's? They just divide out, right? The 2's are going to divide out, and we're just left with the square root of 3 over 1. I want you to see how you can find that square root of 3 and square root of 1 just looking at the y and x at 60 degrees. So for our tangents, the shortcut is we want to focus our attention strictly on the numerator. Now this only works for tangents, but if you notice, we look at the numerator of the y over the numerator of the x, we're going to get our answer. We don't have to worry about those denominators because they're going to divide out when we do our keep it, change it, flip it. Okay, Lucy?
Why are we dividing? Like, why are you dividing?
Because our ratio for tangent is that division of y divided y over x or y divided by x. Does that, I don't know, does that answer your question? Okay. Okay. So the shortcut and what you might want to write kind of as a reminder to yourself here is when we're doing tangents, when it's these three middle ones, for the 0 degrees and 90 degrees, it's a little bit different, and we'll look at that in a second. But for those middle values, we want to do the numerator of the y over the numerator of the x. Okay, so for tangent of 60, that's what we get. Go ahead and write that down, and you may want to write a little note or reminder. Definitely write the reminder about the numerator of the y over the numerator of the x, but 2's will divide out, so do the shortcut. Something to that effect, okay? Okay, so let's look at our other tangent values. Let's look at the tangent of 0 degrees. So for tangent, we're doing y over x at 0 degrees. What's that going to give us? Kira?
What did you say, the tangent of 0?
Yep, tangent at 0 degrees. So we're going to do the y, which is what?
0.
0 over the x, which is 1, and 0 over 1 we know is just 0, right? What about the tangent at 90 degrees? Caden, tangent at 90 degrees. We're going to do y, which is what? 1 over 0, good. And that is, we know that's undefined, right? Okay, let's look at the tangent of 45 degrees. This one's the easiest. Tangent of 45 degrees, the numerator of the y over the numerator of the x. Notice what we get. We get root 2 over root 2. Guys, what's that equal to? 1. Yes. So all of our 45-degree reference angles, when you take the tangent, it's either going to be 1 or it might be -1. Keep that in mind. That's what that's telling us. Okay, here's the last one. It's the trickiest of them. Yeah. Okay, so for tangent of 30, we want to do numerator of the y. Jace, what would that be?
Numerator of the y.
At 30 degrees.
2.
Numerator of the y.
The square root of 3.
I want
don't
to check.
know, I'm lost.
At 30 degrees, numerator of the y.
A 1?
1, there we go. Okay. Okay, so numerator of the y is 1 over the numerator of the x, Jace?
That would be the 3.
That would be the root 3, good. Okay, so here's why this one's not so pretty, because we get this 1 over square root of 3, and we have to rationalize that, so we get square root of 3 over 3. So that one's not quite so pretty. Okay? Okay. All right, so your homework is a Delta Math where it's asking for you to do this process that we were just looking at here. So cosine values, you're going to look at the x-coordinate. Sine values, we're going to look at the y. Tangent, you're looking at y over x. So keep that in mind, okay? We're going to do another quick brain break, and then I want to talk to you guys about radians. I want you to get radians filled in here on this table, and then if we have time, we'll fill them in on this circle. If not, we'll put the pens away and we'll do it that another day. Okay? I'm hoping we can, but we'll see. So quick brain break. Okay, so let's think about this for a second. We know that pi radians is equal to 180 degrees, right? So what do we have to do to 180 degrees? What do we divide 180 by in order to get to 30? 6, right? If we do 180 divided by 6, we get 30. So that means we need to, for the radians, it's going to be pi over 6. We have to do that same process. So pi over 6 is equivalent to 30 degrees. So flip back over to your front cover, and next to 30 degrees, put a pi over 6. So here's the thing to realize. Any angle, if you ever see a radian measure of something pi over 6, it could be 57 pi over 6. If it's something pi over 6, you know it's a 30-degree reference angle. And then we know some information about what we know about 30-degree reference angles. It's going to be the same. You have to decide which quadrant we're in, because it could be positive or negative, but you know those numbers. Okay, so I need you to think about how we can figure out what these other radian measures are based off of this. We have 30 degrees is pi over 6. 30 times how much to get to 150? 5, right? 30 times 5 gives us 150. So if we multiply this times 5, we get 5 pi over 6. So 150 degrees is equivalent to 5 pi over 6 radians. Similarly, 30 degrees times how much to get to 210? 7. So 7 pi over 6 is 210 degrees. Last one, 30 times how much to get to 330? That's 11 pi over 6. I don't know that we'll have time to get these written in on your circle. If you want to try to get them written in here there real quick, you can, but otherwise we'll deal with it another day, because I want you to just kind of process and think about this process, okay? All right, so similar thing, let's talk 45 degrees. We know pi radians is 180 degrees. And so now what do we divide 180 by in order to get 45? And that would be 4. So pi over 4 is equal to 45 degrees. So that means here, this is pi over 4. We're going to do a similar process again. This one's a little bit harder to do the mental math on this. 45 times how much to get to 135? That would be 3 pi over 4. And then 45 times what to get to 225? And that is 5 pi over 4. And then last one, 45 times how much to get to 315? That is 7 pi over 4. Yes, you need to start getting these memorized also. So not just the degree measures, but those radians as well. Flashcards are a good way to deal with that. I'm going to try to teach you a few little tricks with this too as well, I promise. But yeah. Okay, last one. Pi is equal to 180 degrees. What do we have to divide by in order to get to 60? We divide by how much? 3. So pi over 3 is equal to 60 degrees. So pi over 3. And 60 times how much to get to 120? That's 2. 60 times what to get to 240? That's 4. And 60 times 5 gets us to 300. So 5 pi over 3. Okay? Yeah, I don't. Let's kind of get some cleanup done. I know you need to get packed up. We'll have to finish getting radian measures put on your circle. Oh, sweetie.